Alright class, in this lesson we're going to learn about rationalizing the denominator, and what we're going to notice is that this is a square root of 7 is also called an irrational number, in other words not irrational, and our desire is to rationalize it, in other words make it not have a square root in the bottom. And we do that through a simple process of multiplying the top and the bottom by the square root of whatever the bottom is. And what happens is the square root of 7 times the square root of 7 gives me the square root of 49. And what's nice about that is we end up with just 7, because the square root of 49 is 7. So what I successfully did was get rid of the square root on the bottom. All you have to do to finish is multiply the top. So this turns into 3 root 7. There's nothing I can do with that, so I just write 3 root 7. So this is my final answer. Now, there is no square root on the bottom. The square root got moved to the top, and that's a rationalized expression. Now, the problem is I have many students that get really excited because they see the two 7s and they try to cancel them and say, yes, they cancel. So my answer is just 3. Well, it's actually not. You cannot cancel these because you have square root of 7 on top, regular 7 on bottom. That's as far as you can go. So this is your actual final answer. So now let's look at the next problem. The next problem has two 5s, and again, the quickest thing that I see students do is they try to cancel those 5s, and that is a mistake. We can't do those. What I need to do is multiply the top and the bottom by the square root of 5 to rationalize this expression. And when I do that, that turns into the square root of 25 on the bottom, and that ends up with just a 5. Now what I'm going to eventually start doing is I skip this step in the middle, because what you're seeing is that when I multiply the square root by itself, you really just end up with the number inside with no square root symbol. That's our goal. That's what we're really trying to do. Now on the top, what we need to do is work it out. If I multiply 5 root 2 times root 5, you actually just need to multiply the 2 times the 5 to get 5 root 2 times 5, which turns into 5 root 10. Now, I can actually do some further simplifying. This would be my final answer if these 5s weren't going to simplify like these do. These simplify because they don't have square roots over them. It's just 5 over 5. They cancel to be just the square root of 10. This one has a very simplified final answer with no fraction in it. So do look at the end if you can actually cancel out any of the numbers that are left over in front. So this next problem is similar. We've got square root of 12 and then a negative 6 on top. So I need to multiply top and bottom by square root of 12. But before I do that, I could actually try to simplify first. My square root of 12, I could actually hockey stick the 12 and divide by 2 and get 6. Divide by 2 again and I get 3. So it actually reduces first, and we want to look for that each time. Now notice these first problems, I had a 7 and a 5. They were prime numbers, so I didn't work and worry about doing the hockey stick. But this one does, and I can actually rewrite the 12 to be 2 root 3. And on top I got negative 6. And this is really helpful because I have less to multiply, because the 3 is a little bit nicer than 12. Also, the 2 and the 6 can reduce to turn into a 3 on top and a 1 on the bottom. So I further reduced the problem before I even get multiplying to be negative 3 over square root of 3. Okay. Now is the time that I actually want to multiply top and bottom by the square root of 3. And this will give me just a 3 on the bottom. So 3 on the bottom, and then on top I get negative 3 root 3. And to finish, I should notice that the 3 and the negative 3 on top should simplify, they should cancel, and I should just be left with negative root 3 as my final answer for that problem. Okay, so now it's nice to reduce them first, but you don't always have to reduce them first. I'll do the same problem where I don't actually reduce it first. So instead I could have just multiplied the top and the bottom by the square root of 12, and it's actually a little bit quicker. negative 6, square root of 12 on top, and on the bottom this should just turn into a 12. Then to finish, I should just reduce these. 6 and 12 should reduce by 6 to be 1/2. So it's negative square root of 12 over 2. Now you should go ahead and, you do need to rationalize the 12 at this point though, and this should turn into a hockey stick problem where we have 12, and we do our 2, and we get our 6, 2 and 3, just like we did before. Pull out a 2. So then you end up with negative 2 root 3 over 2, and then the 2's cancel, and I'm left with root negative 3. So same answer, whether one was easier than the other one, this is the final answer, negative root 3. Now taking a look at this next problem, we've got a square root of a whole fraction. Now whenever you see this, we generally, if you can't reduce it the way it's set up, which you can't reduce 18 and 125, you need to rewrite it to be this negative square root of the top number divided by the square root of the bottom number. Now these are equivalent expressions, they mean the same thing, square root of the whole thing or the square root of the top over the square root of the bottom. And what I usually write as a rule is that the square root of a fraction needs to turn into the square root of the top over the square root of the bottom. So that's what I just did. I took the square root of the whole fraction, made it square root of the top over square root of the bottom. And now I want to simplify if possible, because I don't really prefer to multiply top and bottom by square root of 125. So I want to hockey stick my 18, and that's going to give me 2 and 9, 3 and 3. In other words, the 18 is going to turn into negative 3 square root of 2. The bottom, the 125, hockey stick that, and that's going to turn into 5 times 25, and then 5 and 5 again, which means that that's going to turn into 5 root 5. And so you can see this time it really is helpful to reduce first, because now I want to take a look and just multiply the top and bottom by square root of 5, which is much better than multiplying by 125. So now I just have to multiply top and bottom by root 5, and that's going to give me negative 3 root 10, because the 2 and the 5 give you the 10, and then on the bottom you get 5, because this 5 comes over, and then here's the tricky part, you get a new 5, an extra one, because the square root of 5 times the square root of 5 gives you another 5. So don't lose that one, don't get lost there. Square root of 5 times square root of 5 gives you the second 5. We already had a 5 there. So now I just need to further simplify, because the bottom multiplies to be 25, so it's negative 3 root 10 over 25. And because the 10 can't simplify, then nothing will reduce. This is my final answer, negative 3 root 10 over 25 for that problem. And now we'll do one more normal problem of rationalizing the denominator. And this one is an example where, again, we should break it up as square root of a whole fraction. We want to do square root of top, 50, m to the 4th, over the square root of the bottom, m square root of p to the 5th. Now, before I multiply, it would be pretty easy to go ahead and multiply top and bottom by square root of p to the 5th, but I can actually simplify first, and we found so far that that's really better. The top, I could take my 50, do a hockey stick, and get 2 and 25, 5 and 5. So that gives me 5 root 2. Actually, I'm going to give myself a little space. Root 2. And then the m to the 4th. What you want to do is you take your 4 and divide it by what the number in front was, which is a 2. And because it goes in twice, that means I get to pull out 2 m's. In other words, m squared. Okay. Now on the bottom, you take your 5 and divide it by the number that was in front, which is, it's a square root, so it's a 2. So 5 divided by 2, it goes in twice, but there's 1 left over. So in other words, if you did long division, it'd be 5 divided by 2, it goes in twice with a remainder of 1. Now what that means is that I get to pull out p to the 2nd power, But whatever the remainder is, that's how many are left on the inside of the square root, p to the first power, just a p. You don't have to put the first power, but just putting it there so that it's clear. Okay, so now to finish, or to move forward after you simplified, I need to just multiply the top and the bottom by the square root of p. So, and that gets what I'm trying to do is get rid of the square root there. So your final answer is going to turn into 5m to the second square root of 2p over p squared, and you times it by one more p, because this part right here gives you this second p. So the final answer, sorry I said it's final answer, but the last answer you need to do is actually combine this part and get p to the third. So it should all be over p to the third, and I'm kind of running out of room, so I'm going to go ahead and erase. So this will turn into p to the third on the bottom as your final answer. So this would be your boxed final answer. Okay?